This is Algebra 2, Lesson 8.4. We are introducing log functions, Part 2. At example number 2, we got through about half of example number 2 yesterday, so we're picking up on 2b, where we'll redo 2b real quick. Log base 1 half of 0.25. Evaluating a log expression or evaluating an expression, you're determining what number you have to raise the base to get 0.25. So as we're looking at the first one, it says 1 half to what power gives 0.25. Yesterday we talked about instead of leaving it as a decimal 0.25, it's easier to make it into a fraction. This is the 100th place. You always go to the farthest one on the right or the last digit that's given. That's the 100th place. And then put the number that's over it. So it's 25 over 100. Now that's a perfectly fine fraction, but we can make a way smaller fraction to deal with. The number 25 goes into 25 and into 100. So we can reduce it with 25 times itself is 1 and times 4 is 100. A lot of y'all, when you seen 0.25, you knew right away that 0.25 was a quarter or like a quarter of a dollar. So 1/4 is your smaller version. Um, but it's asking you, what do you need to raise 1 half to get 1/4? So the top number, if you raise 1 half to the second power, it doesn't matter how many times you multiply 1 by itself, it'll stay 1. But when you multiply 2 times itself twice, you'll get 4. So in order to get 0.25 out of 1 half, or in order to get 1/4 out of 1 half, you need to raise 1 half to the number 2. C asks you, um, 1/3 to what power gives 27? Okay, first off, remember what the elevator rule does. This is not the number 3. It's the number 1/3, but you can clearly see the number 3 at the bottom. So you know you're trying to go from a fraction to an integer number, a number that doesn't have a numerator and a denominator shown. So you need to flip it right away. So you know how to flip something, you raise it to a negative exponent. So it's simply a negative exponent. And then you're asking yourself, what do you have to, how many times do you have to multiply 3 by itself to get the number 27? So it'll be, you have to multiply 3 times itself 3 times to get 27. So you're raising it to the negative third power. And again, the negative itself will go to both of them just like it did on B. It'll go to this one and it'll go to this one. So it'll actually wind up flipping both of them. The one will go down, the 3 will go up. It doesn't matter how many times you multiply 3 by itself, it stays 1. I'm sorry, 1 by itself, it stays 3. But 3 times itself 3 times gives you 27. And then D says 4 to what power gives 2? Okay, so remember we talked about taking um, radical form or exponential form and going to radical form going to exponential form. We did this last week. 4 raised to what power is going to give you the number 2? Notice it's not flipping it, so you know it's not going to be a negative value. And it doesn't matter how many times you multiply 4 by itself, you're never going to get to the number 2. So you need to multiply it by itself, something smaller than the number 1. You can't multiply it by itself one time because it's going to give you at least the number 4. So exponentially, we said that this 1 half, it winds up being 1 half. But we said this 1 half down here, um, if it's raised to the 1 half power, we said that this was the root. So if you made it look like this, it'll say the square root, or that's the index, of the big number or the radicand 4. And this number right here is what you raise it to. A shortcut a lot of people will see with this is anytime you raise something to the 1 half power, you know that that is taking the square root of it. Anytime you raise something to the 1/3 power, the cube root, the 1/4 power, the quad root, and it keeps going like that. So anytime you see 1 over a number, you're taking that index root of it. On the back, everybody. Let's evaluate these. Log base 4 of 64 is what? Take about 30 seconds on this one. And again, we had a really similar example to this on your homework last night. What it's asking you is 4. This is how you set this problem up. This is the base right here, log base 4. 4 to the what power is 64. That's how you want to look at that. Remember, I gave y'all a little chart that has all the the exponents and stuff like that on it, all the way up to 10 to the 10th power. You can use that, or you can just ask yourself and just count. When you multiply 4 times itself twice, you get 16. Times itself again a third time, you get the number 64. So the answer to this, when you evaluate it, is simply 3. This is 3. Okay, what about this next one? What about the log base 2 of 0.125? Remember, don't leave it as a decimal. Change it to a fraction. What is 125? What digit is it talking about? Here's a trick for you if you're getting stuck on what is 0.125. It's probably going to be a multiple of the number 2, because you're asking yourself, what do you have to raise 2 to become 0.125? You can clearly see that 0.125 is not a whole number. It's something smaller than the number 1. What I told y'all about the places, remember, this is your tenths place, hundredths place, thousandths place. So it's over 1,000, the number 125, this whole thing. 125 over 1,000. Now, that's not as easy for most people to see. So when you look at that, how many times does the number, you might not know that 125 goes into 1,000 evenly, but you do know that 25 does. Let's say 25 goes into this one. It goes into it 5 times. So 5. And 25, you know it goes into 100 4 times. And then you got to add one more zero on it. So you got 5 over 40, so it's almost reduced. The number 5, you know, goes into itself 1 time and into 48 times. So this is what I was talking about a little bit of a shortcut. You know it's going to be some number that you can raise 2 to an exponent 2 to get to. We know we can make 2 into the number 8 by raising it to the third power. But it's not, this is not raising it to the third power, because 1 over 8 is not 8. Remember, anytime you're making something from an integer number to a fraction, or something where it has to go down or ride the elevator, um, it looks like this: log base 2, or that's what it says, log base 2. When you write it in exponential form, it's easier to see. 2 to the what power is 0.0125. So it looks something like this. 2 to the what power is equal to that. Remember, in order to make a fraction, automatically it's going to be negative. 2 to the negative something power. And then, like I said a second ago, 2 times itself twice is 4, times itself a third time is 8. So it's actually negative third power for that one. What about this one? Log base 1/4 of 256. And again, I see a lot of fingers frantically touching calculator buttons and stuff. This stuff is made to where you don't need calculators. First thing you have to know when you look at this is you're taking a fraction 1/4 and you're making it into an integer number. It's no longer a fraction on the other side of the equal sign. So you know you have to ride the elevator to make 4 go up to the top. So you have to make the first part of it, you need to be able to look at that and realize it's going to be a negative exponent. Then it's simply, what are you raising 4 to to get the number 256. So just look at your chart, go to 4, and then slide over to the right till you see 256. When you look up, you see it's the number 4. So 4 to the fourth power is 256. And again, 1/4 becomes 256 by raising it to a negative exponent. What about this last one? Unlike the other ones, look at it. You're going now from a bigger number to a smaller number. So remember, we had one like this a little while ago, where we did the 1/3 power of something, or remember the 1/2 power means you're taking the square root of it. The 1/3 power means you're taking the cube root. 1/4 power means the fourth root. What this is asking you, which root of the number 32 is 2? So the way you look at your chart for that one, go look to the left where it says 2, and then just scroll on over till you find 32, and you can see that 32 raised to the fifth power is 2. But remember, it's not 5. Let's just look at the number 5 for a second. It's not 5. If you multiply 32 times itself 5 times, you're going to get a great big number. It's not 5. It's asking you which root of it. So it's actually, it won't fit in here. It's actually 1 over 5. That's what you're raising 32 to get the number 2, the 1/5 power. Then we have two checkpoint problems. It says log base 5 of 125 is what? So 5 to the what power is 125? This should be a simple one. You know that 5 to the third power is 125. And log base 8 of 2. So base 8 of what? Or I'm reading it wrong now because I'm trying to write it and talk at the same time. But log base 8 of 2 is what? Here's one where 8 becomes a smaller number 2. Remember, I know that fractions are smaller numbers than whole numbers, but when you're just looking at the denominator or just the numerator, you can see the larger number it becomes. This is one of those instances where it doesn't flip. You do not use a negative to make it flip, but 8 becomes a smaller number. So you know you're going to raise it to 1 over whatever number is, which root of 8 is 2. So it's the 1/3 power. So 8 to the 1/3 power is 2. Example number 3 is using inverse properties. Mentioned real quickly yesterday before we started rewriting them, um, that logs, if they don't have a number, like right here it says log base 2. If there's no base given, we said that it's assumed that it's log base 10. 10 is the number that you don't write as log. And this is what I was talking about earlier, where you're actually trying to make numbers smaller to where you can manipulate them without a calculator. So right here, what you want is a base that is the same as the exponent. This log, this 10 right here, and this log base 10, what they wind up doing with each other is canceling each other out. So that's the goal, is to get them canceled out. As we see more examples, you'll see what I'm talking about that. But 10 to the log of 2.3, that's how you read that. 10 and log cancel each other out, and it's simply 2.3. That being said, we're trying to do the same thing for the second one. Log base 2 of 8 to the x power. But you can clearly see this one was the same as this log base 10. This one, too, is not the same as 8. Okay, and here is the most important part of this lesson. So if you're not paying attention to this point, sit up and pay attention. This is the most important part. You want this number to be the same as this number. So you have to ask yourself, what do I need to raise 2 to make it equal to 8? So it's the same question we said a second ago. 2 to the what power is 8? This is converting the bases. This is what this lesson's all about. Okay, you know that 2 to the second power is 4, to the third power is 8. So this number right here becomes 3. So 8 is the same thing as 2 to the third power. You have to understand that concept. That is the trick, and that is the hang up that people have with logarithms. 8 is the same thing as 2 to the third power. So once you do 2 to the third power, you have something that looks like this. Log base 2 of 2 to the third power to the x power. This now is allowed to, this cancels this out. And now you're left with 3 times x. Or this cancels this out. And you're left with 3 times x. We're going to look at another one to make that make sense in a second. You have to convert the bases to be the same. Once they're the same, they can eliminate, and you get back to smaller numbers that you can manipulate and work with. On the back one more time. Nope. Hold on one second. Here we go. Let's simplify this expression. 10 to the log of x. Remember, you want the exponent to be the same as base. You can clearly see that, remember, 10 is the unwritten base with logarithms. So this is saying 10 to the log base 10. They eliminate each other. X is the simplified answer. It's real simple. That should be real simple. The other one, you have to manipulate it a little bit. It says log base 5 of 125 to the x. I have to change this one. Okay, again, you have to change this one. You want to change, you have log now base 5. 5. So you want to change 125 to base 5 raised to some power. Which exponent do you raise 5 to make it 125? Yeah, when you raise it to the second power, you get 25. To the third power, you get 125. So now it becomes 5 to the third power to the x power. That's just bringing this part back. Is log base 5 of 5 to the third to the x. So now you have log base 5 and 5. This cancels this, and you're simply left with 3x. 3x. All you're doing is simplifying it. You can't make it equal to anything. You're eliminating things to where we can solve equations with them. Okay. Well, this is the introduction to changing bases. Okay, inverses, we're going to leave that for another lesson. So log, here's the last checkpoint. 10 log x, or 10 to the log of x. Okay, so this is just, this eliminates this. This is just x. Okay. What about log base 3 of 81 to the x? You have to make the change of the base. So you want it to be the same as that log base 3. So you need to change 81 to 3 to the something power. Okay, what I mean by that something power, you raise 3 to the second power, you know, you get 9. To the third power, you get 27. To the fourth power is 81. So it becomes 3 to the fourth power to the x. This is the exact same thing as what's written right above it. But what it allows you to do is simplify the numbers. That's what we're doing, simplifying them to make smaller numbers to where we cannot have to use calculators and stuff. That's what this is about. So now it's log base 3 of 3 to the fourth power to the x power. That's how you read that, as goofy as that sounds. And this, since it's the same as this, eliminates it. Then you're left with 4x. And that's all we can do with this, with as far as simplifying it goes.